All right, I'm going to move a little bit faster in this video because I'm assuming you watched the first part and then hopefully you kind of understand what's going on. All right, so in this problem, we're on number 5. You don't know what's in the eye. You tried to neutralize emotions by seeing different distances. You find neutral with the plano mirror oriented at 90 degrees, and you find neutral with the concave mirror oriented at 180 degrees at these two distances. Okay, this is, if you take one thing away from all the stuff I've been saying, it's this, okay? When you see neutral, it doesn't matter if it's the plano mirror, it doesn't matter if it's the concave mirror. It's the same thing, okay? So there's no changing of the signs. Neutral is the same between the two mirrors. There's a difference between the two mirrors, which we'll talk about in a problem coming up later. But if they see neutral, it doesn't matter what mirror they're using, okay? And so we have them finding neutral at 36.36 centimeters with the plane mirror oriented at 90 degrees. If it's oriented at 90, it's the same thing as saying it's parallel to 90, meaning we're scoping the 180. Okay, so whatever like number is at axis 180, we neutralize that at 36.36 centimeters, okay? Without changing anything in the phoropter, okay? So you can think of it simply as you take out your 36.36 centimeters working distance, which is 2.75. So you take out 2.75 diopters, and you end up with minus 2.75 as your value for that. Or if you want to just be very careful, you can do the formula. So that's gross plus working distance equals net. Our gross is 0 because we haven't changed any numbers in the phoropter. Our working distance is minus 2.75 because it's 36.36 centimeters. 100 divided by 36.36 is 2.75 equals net. And so then our net equals minus 2.75. All right, I'm just going to get rid of this. Okay, so at 100, actually I'll do it like this. Minus 2.75 is our number at 180 degrees. Okay, so then you find neutral with the concave mirror oriented at 180 degrees at 28.57 centimeters. Okay, so again, it's the concave mirror, which I feel like you think is making you think, oh, we need to switch the signs. There's no switching of signs. If it's neutral, it's the same thing. So it's oriented at 180 degrees, which means we're scoping the 90th. And so for scoping the 90th, whatever we find here is whatever number will be at 90 degrees. Okay, so then we find neutral at 28.57 centimeters. So I can do the formula again just to make sure everything is clear. So our gross is 0. Our working distance is 3.5 because 100 over 28.57 is 3.5. So minus 3.5 equals our net. So our net equals minus 3.5. Okay, and so then I'm going to erase this part. Minus 3.5 at axis 90. Okay, and so we have our two meridians, and we can get our final prescription. So the less minus or the most plus 1 is minus 2.75, so that's our first number. Our axis corresponds to that, so our axis is 180. And then our CIL is just the difference between these two, which is minus 0.75. And so there's our answer. Okay, and then so we're at number 6. When practicing with the patient, you're working at 50 centimeters, so that means our working distance is 2 diopters. You remove their prescription glasses that you know to be minus 2, minus 150, axis 90. So now we already know their refractive error is minus 2, minus 150, axis 90. I don't know why I'm rewriting it. It's like right there, but I'm just going to keep going. Okay, so then light from optical infinity would focus where as compared to the retina? Okay, so this isn't a trick question. If it's a ametropic patient, it would focus light on the retina. If it's a hyperopic patient, the eye is too weak, it wouldn't be able to converge the light as powerfully as a regular eye, so the image would focus behind the retina. A myope has an eye that's more powerful than a regular eye, and so it focuses light too early. So then it would focus light in front of the retina. Okay. What motion would you see when your streak is oriented at 90 degrees? Okay, again, so we're oriented at 90 degrees, which means we're scoping the 180. Okay, so far all the problems have been saying that our light has been oriented at a particular direction, but read the questions carefully, because sometimes she will just write, when you are scoping the 180, you see this, in which case you don't have to flip anything. Okay, so we're scoping the 180. What motion would we see? So if we're scoping the 180, let's draw an optical cross of the prescription. So we have, here's an optical cross. This is axis 90 right here, and that's where -2 goes. And then minus 350, minus 150 is the difference between these two. So then minus 350 would be at axis 180. Okay, so if we're scoping the 180, we're scoping this. So we're scoping minus 350, which means that's our net. So our minus 350 is our net, equals working distance, which is -2. And then we're trying to find our gross. Okay, so that means our gross equals minus 150. So again, it's saying what motion would you see? All you're looking for is whether it's a positive number, a negative number, or a 0. And since it's negative, we will see against motion. Now, if the question said how much against motion would you see, you'd say 1.5 diopters of against motion. Okay, and then let's move on to the next part. So I'm not going to do the math for this one. I think you have seen a few examples of me doing it like that. I'm just going to walk you through how I do these in my head. So what motion would you see with your streak oriented at 180 degrees? Okay, so our streak is oriented at 180 degrees, so we're scoping the 90. Okay, here's how I think of it. Our working distance is -2. We're scoping the 90th, so we're scoping -2. Now, what you need to think of is the meridian I'm scoping more plus, more minus, or equal to my working distance? If it's equal, you see neutral or no motion. Okay? If it's more minus, you see against. Okay, just like part B, where we are scoping minus 350, but our working distance is -2. Minus 350 is more minus than -2, so we would see against motion. And then if the meridian you were scoping was more plus, you'd see with. The reason I bring that up is, so we've already solved this part, where working distance is -2, we're scoping -2, which means we would see neutral and no motion. Okay, the reason I'm saying that is, let's have a hypothetical situation. Let's have the same exact problem, but we're scoping a meridian like that has a power of -150. So let me draw that. Okay, so we're scoping -150. Our working distance is -2. So first I'll do the math. So we have gross -2 equals -150, and if we solve for gross, we end up with a positive number. So we know that would be with motion. Okay. The reason I'm pointing this out is, if you ignore everything and you're like, okay, I'm scoping -150, it's a minus number, I'm definitely going to see against motion, that would be wrong. Okay, so you have to factor in your working distance. I feel like when I first started doing these problems, I'd be confused about why I would have a minus meridian, but I'd be ending up with motion. So this is just something to keep in mind. Let me erase this. Okay, and then what would be the gross lens to get neutral at 50 centimeters? Okay, so then we have gross, and remember, when we're solving for gross lenses for a prescription where there's like like a spherocylindrical component, I'm saying just focus on the sphere part for now. So gross, we don't know. Our working distance is -2, and that equals our sphere, which is -2. So then our gross equals -2 plus 2 is so gross equals 0. So then we'd have plano, and then the sill and the axis stays the same. So remember, our sill and axis are up here. Plano -1.5, axis 90. All right, so then we'll move on to this one. You're practicing with a patient at a working distance of 50 centimeters. You remove their glasses. You know their prescription is +350 -1, axis 180. And then working distance is still 50 centimeters. Okay, so working distance still -2. And then I'll draw the optical cross. So we have +350 at axis 180. And then at axis 90, we have -1 sill, so the difference. And then that's +250. Okay, so then what motion would you see when your streak is oriented at 90 degrees? So if we're oriented at 90 degrees, we're scoping the 180, so we're scoping +350. And our working distance is -2. So our -2 is more minus than +350. So then, sorry, you think of it as comparing what you're scoping to the working distance. So what we're scoping is +350, which is more plus than -2, so we'd see with motion. If you want to like be sure, we can solve for it. So gross -2 equals +350, and then so gross equals +550. Okay, and then if you want to make it even shorter than that, if you're scoping a plus meridian, no matter what, you're going to see with motion to start off with. Okay, it gets complicated when you're scoping minus meridians, but if you're scoping any sort of plus, you're always going to be seeing with motion. Okay. Unless that is, of course, we use the concave mirror, but let's not worry about that. I don't think they're going to make it that complicated. Okay, so then, actually, why did I erase that? So what motion would you see if your streak is oriented at 180 degrees? So we're scoping +250. +250 is more plus than -2. So then we're going to see with motion. Okay, what gross lens to get neutral at 50 centimeters? So here's gross -2. And then remember, we're doing just the sphere. So equals +350. And so gross equals +550. And so then our gross lenses would be +550 and the same sill, so -1, and the same axis 180. Okay, and then part D, what would the gross lens be to get neutral at 67 centimeters? 67 centimeters is 150 working distance. We have gross -150 equals our net, which is +350. And then so our gross equals +5. And so then our final gross lens would be +550. Sorry, not +550, +5. I just blanked really hard for a second. +5 -1, axis 180. All right, so for this problem, we're doing lens rack ret, which I don't think she will ask you a question about because that's something we do next semester. But we'll do the problem anyway. So the student sees with motion with the streak oriented parallel to axis 90, and they use 2.25 diopters, okay? And then with the streak parallel to axis 180, using the concave mirror, they see with motion and 1.25 diopters. And then we'll worry about the working distance a little bit later. Okay, so let's just break this question down sentence by sentence. So let's focus on the first one. It doesn't say it, but it implies it, that in the first sentence we're using the plano mirror. I'm just assuming that because the second sentence says we switch to the concave mirror. Okay, so the plano mirror is what we're all used to, where like we see against, I'm just gonna write this down, against is minus and width is plus. Okay, so it's what we're used to in lab. We always have the sleeve down, so we're using the plano mirror. Okay, so then this is normal. We see with motion, so we know it's plus, and we use 2.25 diopter lenses, so 2.25. So we have plus 225 with our streak-oriented parallel to axis 90, which means we're scoping 180. So we see 2.25 at 180. And this is not the net yet. Remember, we haven't taken out the working distance. So before taking out the working distance, we have plus 225 at axis 180. Okay, and then let's move on to the second sentence. So the only thing that's different here is that we use the concave mirror. And the concave mirror is the exact opposite. So this, what I wrote here, is for the plano. For the concave, against equals plus, with equals minus. That's really confusing for me, so I just switch them. So I write it down on my paper. So what I would have written, hypothetically, if this was an exam, going back to the first part of the question, I would have written with like 2.25 parallel to 90, and then for the second part, I wouldn't write it out. I would probably just replace it as I write it, but I'll show you what I'm thinking. I would write with maybe something like concave 1.25 parallel to 180. And then what I would have actually written is I would have read that it says with motion with the concave, and I would have just written against. Okay, so I'm just going to repeat that again. Whenever you see any motion with the concave mirror, with the plano mirror, you would see the opposite. And we're used to the plano mirror, so I just flip it. And that's if you see any motion. If you see neutral, there is no changing of any signs, and you don't change anything. Okay, so I'm just going to erase this. Okay, so then we'll keep working on that second sentence. So we see 1.25 diopters. We're using 1.25 diopters lens, and then we see with motion. But since that's a concave mirror, we're thinking the opposite. So it's technically against motion, and against is minus. Against at, and since it's parallel to the 180, we're streaking the 90. All right, so number 8, we are performing lens retinoscopy, which I don't think you guys know what that is yet. So I don't expect her to ask a question like this, but let's just go over it anyway, just in case. So let's work on it sentence by sentence. The student sees with motion, with motion, and achieves neutrality with the streak-oriented parallel with axis 90 using a 2.25 diopter lens. So let's just write all the important facts. So we see with motion, parallel to 90, and 2.25 diopters. Okay, so with motion equals plus. So I'm just going to remind you, with equals plus, against equals minus. And this is just for the plano mirror, which is what we're used to. What we use in lab with the sleeve down, that's the plano mirror. So that should make sense to you. And I'm assuming in this first sentence we're using the plano mirror, even though it doesn't say it, because in the second sentence it says we switch to the concave mirror. Okay, so still focusing on the first sentence, we see 2.25 diopters of with motion parallel to the 90. So that means since it's parallel to the 90, we're scoping 180. Okay, so what we know is that we see plus 2.25 at axis 180. Okay, and then let's focus on the second sentence now. Sorry, I'm just going to move this up. Plus 2.25 at 180. Okay. And so now we have the streak parallel to axis 180. So parallel to 180, which is the same thing as scoping 90. The student switching to the concave mirror sees with motion. Okay, so this is the part where I would encourage you to read questions carefully and write down stuff as you go. So if we're switching to the concave mirror and we see with motion, whatever you see on the concave mirror in terms of motion would be opposite for the plano mirror, which is what we're used to. Okay, so if you see with motion with the concave mirror, you would see against motion in the same situation with the plano mirror. Okay, and then vice versa. So if you saw against motion with the concave mirror, you would see with motion with the plano mirror. And I'm going to repeat what I said earlier. If you see neutral with one, you would see neutral with the other. And you don't flip anything for that. It's the same, like you don't change any signs. It's the same situation. Okay, so we see with motion with the concave mirror. So if I was on the actual exam, I would write against, and then with a 1.25 diopter lens. Okay, so against is minus. We have 1.25 diopters, and we're scoping the 90. So we have minus 1.25 at axis 90. All right, let me erase that. So we have minus 1.25 at 90. All right, and then, so these are our, these are our gross lenses because we haven't taken any working distance out yet. So I'm just going to draw an optical cross of what we have so far. So we have plus 225 here, and we have minus 1.25 here. So our like total like final refractive error is plus 2.25, and then the difference between minus 1.25 and plus 2.25 is minus 3.5, and then our axis is the more plus meridian, which is this one, so it's axis 180. Okay, what would be the gross lenses to get neutral at 67 centimeters? I don't really get what that question is asking, so I'm just going to ignore it. Okay, what would be the net lenses for this patient? Okay, so we have the plus 225 minus 350 axis 180. So we'll do, remember we're just going with the sphere, so we'll do plus 225 as our gross. And then our working distance, which is 67 centimeters, which is minus 150. And then that equals our net. So our net would be plus 225 minus 150, so that's plus 75 equals our net. And so then our final Rx would be plus 75 minus 350 axis 180.